Good morning, students. Jai Swaminarayan. Welcome to our video lecture. Today, students, we are going to start with a new topic, and that topic is permutations of identical objects. Permutations of identical objects. Now, we have studied only permutation where the definition was given are n distinct items, objects or things out of which r items can be arranged in NPR ways, and that is called permutation of r items. So the total arrangement of r items out of given n items is called permutations of r items, and it was denoted by NPR. The formula of NPR is n factorial divided by n minus r factorial, where r can be in the range of 0 to n. Students, this was our basic fundamental understanding with permutation. Now, suppose students I have 10 pens, of which 4 are black, 3 are green, and say 3 are blue. Say students, we have 10 pens, out of which 4 are black, 3 are green, and 3 are blue. 4 black pens are identical. Say this type of markers identical in size, shape, and color. Same way, 3 green pens are identical in size, shape, and color. And similarly for 3 blue. Now, if there are 10 distinct pens, the total arrangements would be definitely, students, total arrangements would be definitely 10 factorial. But here I have to divide by 4 factorial, 3 factorial, 3 factorial. Say there are 10 distinct pens or 10 pens, out of which 4 are black, 3 are green, and 3 are blue. So this 4 identical black pens will not be arranged in different ways. These 4 pens can be arranged in only one way. Similarly, 3 green pens can be arranged in only one way, and similarly 3 blue pens can be arranged in only one way. So, suppose we have 10 different pens, or 10 pens I should say, in which 4 are black, 3 are green, and 3 are blue. Then the total arrangements are 10 factorial divided by 4 factorial into 3 factorial into 3 factorial. The reason or logic for this is the internal permutations of 4 black pens can be done in only one way. Similarly for 3 green, and similarly for 3 blue. So in general, we have n objects, out of which p are of one type, q are of second type, and r are of third type. Then the total permutations of this objects is n factorial divided by p factorial into q factorial into r factorial. This is what, students, we have in terms of permutation with identical objects. So the formula or concept or theory goes like this, students. Suppose we have n items, out of which p are of one type, q are of second type, and r are of third type, where p items are identical in size, shape, and color. Similarly for q, similarly for r. Then the total permutations of these n objects is n factorial divided by p factorial into q factorial into r factorial. This is what is, students, the you can say concept of permutations with identical objects. Let us take one example. Say we have the word statistics Now, the total letters are 3 and 3, 6 and 4, 10. So, n is equal to 10. Now, S is repeated thrice. T is repeated thrice. I is repeated twice. And you can say A and C are repeated once each. So 6 and 2, 8 and 2, 10. Then the total permutations of this word, total permutations are 10 factorial divided by 3 factorial, 3 factorial, 2 factorial, 1 factorial, 1 factorial. The formula is not restricted only to 3 groups of items which are identical. This formula can be generalized for n group of identical items. So this is students permutations with identical objects. Now we start exercise 7.3, sum number 8 onwards. Now, using all the letters of the word equation, once only, how many words can be formed which can be meaningful or meaningless? Now pay attention students, the word equation, E, Q, U, A, T, I, O, N. This has 8 letters. The word equation has n is equal to 8 letters. So I have to form 8 letter words. 8 letter words. So students, correspondingly I draw 8 boxes. Now I have 8 letters and I have to arrange also 8 letters. So 8 letters can be arranged in 8 ways, and that is 8 factorial divided by 0 factorial, and that comes out to be 8 factorial. And students, answer of 8 factorial is 40,320. So total words formed are 40,320. The words may have meaning or not, students. That is altogether a secondary thing. So the same sum out of 8 letters, suppose if I want to arrange any 3 letters, then it can be done in 8p 3 ways. If I had to arrange any 5 letters, it can be done in 8p 5 ways. And if I have to arrange all 8 letters, then this can be done in 8p8. That is 8 factorial ways. So this is how students will use the concept of permutation, and be careful that here repetition is not allowed. Now students, next sum number 9 we are doing. So this formula now, I suppose all of you have perfectly understood. Now, students, next concept. Using the letters of the word Monday, once without repetition, how many words can be formed with or without meaning based on the given condition? Okay, students, answer 9. The word Monday has 6 letters, and all 6 letters are distinct. First part of the sum, 4 letter words, 4 letter words. So I have to draw 4 boxes, 1, 2, 3 and 4. Just now I told in the word equation, if we were supposed to use 5 letters out of 8, it is 8p5. Suppose we were to use 6 letters out of 8, then it is 8p6. Here I have to use 4 letters. So total 4 letter words formed will be 64, and that is nothing but 6 factorial upon 2 factorial. So 720 divided by 2, so 360. So the first part of the sum, total words of 4 letters is equal to 360. Now, second part of the sum, we have to use all the 6 letters. So, 6 letter words. So, the 6 letter words, so I have to draw 6 boxes. So, 6 letters and arrangement of all 6. So, arrangement of all 6 can be done in 6 pieces. This is 6 factorial upon 0 factorial. 0 factorial is 1. So, total words of 6 letters is equal to 720. The third part of the sum. The first letter is a vowel, and using all 6 letters, first letter vowel and using all 6 letters once. Now, in the word Monday, we have 2 vowels which are O and A, and we have 4 consonants which are M, N, D, Y. So the first letter is a vowel and remaining 5 can be any in order. So we have 2 vowels. Out of 2 vowels, one can be arranged in 2P1, that is 2 ways. Cumulatively remaining 5 can be arranged in 5P5, that is 5 factorial ways. If the first was a consonant, then out of 4 consonants, any one can occupy in the first place. So the first place can be arranged in 4P1, that is 4 ways. And of course the remaining are 5P5. So total words as per the given condition, 2P1 into 5P5, and that is 2 into 120, and that is nothing but 240. So, the total words of 6 letters where vowel is in the first place, or vowel is the first letter, are 240. And if it was consonant, then 4P1 is 4 into 120, then the total words will become, you can say, 480. Now students, mark 10th and 11th sums as very, very important. Sum number 10 and sum number 11 are very important, students. So you have to be very careful and you have to be very cautious, students, while doing sum number 10 and 11. Now the word Mississippi is given. MISSISSIPP. This is the word Mississippi. Now this same question has been asked in the mains. Using all the letters of the word Mississippi, how many possible permutations are there where 4 I's do not occur together? I's are not together. Now total we count 4 and 4, 8, 11. So total letters are N is equal to 11. Now what we will do? First we will find the total arrangements. N repeated once, I repeated 4 times, S repeated 4 times, P repeated the total permutations are the total permutations are 11 factorial upon 4 factorial, 4 factorial, 2 factorial, 1 factorial. Students, I have simplified beforehand this because I cannot simplify during the lecture using calculator. So let us check what are the total permutations. This comes out to be, students, 34,650. 34,650 distinct words can be formed using all 11 letters of the word Mississippi. This is what is the sum. Now, students, we are going for words where 4 eyes are together, and this demands lot of understanding. Words where 4 eyes are together. And then what we will do, students, we will subtract this from total permutations. Then we will get the words where 4 eyes are not together. Directly we cannot go for the words where eyes are not together. Be careful. Now there is an algorithmic approach for when eyes are together or things are together. So this, students, you have to perfectly understand. So which are together, you group them. So 4 eyes are together, so I group them, and whenever you group, you have to consider this as only one letter. Now which are the remaining 7? M, S, 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 P, P. So what I am doing, that you carefully observe. In permutation, whatever items, things, objects are to be kept together, you group them as one. In any place, I have grouped them in first place. Out of 7 plus 1, 8 place, you can group them in any one of the 8 place. Now, first of all, I want to consider all arrangement of this 11, but this 4 is considered as 1. So, this 8 letters can be arranged in 8 factorial divided by 4 factorial into 2 factorial. Why? Because in this 7 plus 1, which is considered as only one letter, S is repeated 4 times and P is repeated twice. This, students, you very carefully understand and monitor. Once again, we have to keep 4 eyes together. So I am grouping all 4 eyes as only one letter. Remaining are 7. Check 7 plus 1, 8 letters can be arranged in 8 factorial ways. But in these 8 letters, S is repeated 4 times and P is repeated twice. So this is total. Now we have to multiply by the arrangement of group. In this group we have 4 eyes. So 4 factorial upon 4 factorial. Because these 4 eyes are repeated 4 times. So in the first tense you go for total arrangements of all 8 letters. And then multiply the internal arrangements within the group. But since in group we have 4 eyes and all 4 eyes are repeated, it means that 4 eyes can be arranged in only one way. But if they all 4 were distinct, they would have multiplied by 4 factorial. So this is the method. First you take 4 eyes as only one letter, remaining 7, 7 plus 1, 8 letters can be arranged in 8 factorial by divided by 4 factorial and 2 factorial because S is repeated 4 times and P is repeated twice. Then go for the multiplication of internal arrangement of group. This will give us total ways where 4 eyes are together and this comes out to be 840. because this gets cancelled. So, total words where 4 eyes are together is 840. Therefore, total words where 4 eyes are not together is equal to 34,650 minus 840, and that works out to be 33,810. 33,810. So this is what, students, we have to do. Directly we cannot get the answer where 4 eyes are not together. So first we have to go for the total words. Then we have gone the words where 4 eyes are together. And from total, if we subtract the words where 4 eyes are together, we get the words where 4 eyes are not together. The same sum as we asked JLB means. So one has to be very careful in doing this type of sums. Okay, now we are going for sum number 11. The word permutations is given, and using all the letters of the word permutation, find the words using the following conditions. The word starting with P and ending with S. Okay, answer 11. We will be doing only 2 parts of answer 11. The third part we will be doing in the next lecture. So students, please be careful. The third part we will do in the next lecture. Count 3 and 3, 6 and 3, 9 and 3, 12. So total letters are 12. Now, in this, only T is repeated twice. So, the first answer, words starting with P and ending with S. The words starting with P and ending with S. This we have to consider. So if I draw 12 boxes, say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here S, and here P. This is first, and this is 12. For remaining 10, which are E, R, N, U, T, A, T, I, O, N. These are 10. So remaining 10 can be arranged in 10 factorial divided by 2. Why? Because in this 10, letters T is repeated twice. P is first, so that can be arranged in only one way. S is last, that can be also arranged in one way. So no need to consider that one. Students, understood or not? P is first. The first letter can be arranged in only one way. So this can be arranged in only one way. And even this S can be arranged in only one way. So, total words starting with P and ending with S will be 10 factorial divided by 2 factorial. Mind you, this is a very, very large number, and that works out to be 18 lakhs 14,400. 18 lakhs 14,400. So here we are talking, students, in terms of lakhs, because number of letters are correspondingly very large. So indirectly, students, here we have to understand that if the letter is repeated, or if you can see you have repeated objects, then you have to divide by the number of that particular factorial. Then all vowels are together, part B. All vowels are together. Now count how many vowels we have. E, U, A, I, O. All 5 vowels we have. Vowels are 5. Consonants are 7. So all vowels are together. So group all 5 vowels in the box. E, U, A, I, O. Group. So group is always considered 1. What are the other consonants? P, R, N, T, T, N, S. So these are 7 consonants. So 7 plus 1, 8 objects can be arranged in 8 factorial divided by 2 factorial. Why? Because in this, T is repeated twice. Now, the internal arrangements of group. In the group, we have 5 vowels, and these 5 vowels can be arranged in 5 ways. Check. Here I don't have to divide. Why? Because out of 5 vowels, any vowel can come first. It is not that E only can come first. The condition is that vowels are together, so their internal arrangement is possible in 5 factorial ways. So, total words where 5 vowels are together is 8 factorial divided by 2 factorial. 5 is 5 factorial. And this is also very large. 24,19,200. 24,19,200. So, these are the total words where 5 vowels are together. Now, if I would have considered 5 consonants together, 7 consonants together, pay attention. One part I am doing extra. Students, one part I am doing extra. Words where 7 consonants are together. Then I group all 7 consonants in the box. P, R, N, T, T, N, S, and then E, U, A, I, O. So these are 5. Consider this as only 1. 5 plus 1, 6 letters can be arranged in 6 factorial ways. Why I did not divide here? Because within these 6 letters, no one is repeated. No letter is repeated. Box inside we have any letters, that is not a problem. Box is only 1 and all 5 vowels are distinct. So in these 6 letters, none is repeated. So 6 letters can be arranged in 6 pieces, that is 6 factorial ways. Now comes the arrangement of box. Here we have 7 letters and divided by 2 factorial. Because within this box, T is repeated. Now check, you can easily compare. So this will be 720 by 2, so 360 into 5040. This is your answer. Now I think students, this concept must be very clear. So when box is considered 1, 5 vowels are distinct. So 5 plus 1, 6 letters can be arranged in 6 factorial ways. And now we have to multiply the arrangement of the box. Check this particular Number indicates the arrangement of box. This also indicates arrangement of box. So first we have to consider the total arrangements. Then the second part, students, we have to consider in general the arrangement of box, and when we multiply both the arrangements, students, this will give us the total words where 7 consonants are together, and this has given us the total words where 5 vowels are together. Now, I suppose, students, easily you can compare and understand. Here I did not divide by anything because within the box 5 vowels were distinct. Within the box, students, the 5 vowels were distinct. Now in the second part which I have done extra, within the box we have 7 consonants where T is repeated twice. So we have divided by 2 factorial. Now I am not multiplying that bigger number. That much, students, I can easily expect from you to do. So the third part of the sum is pending. That I will do in the next lecture because that particular part will require 10 minutes. So students, do not worry, I have not forgotten the third part, but that third part, students, I will be doing in the next lecture. So here we conclude the lecture, students. Do all these sums twice, once you do with looking, and students, once you do the sums without looking. Thank you, students.